Hello everyone, this is Mrs. Lindsay. Today we're just going to go through a couple of your problems from practice set number 3. I'm going to go ahead and start here with number 1. Again, I typically always take a look at this and I want to try to simplify it if I can. Let's see if we can actually factor this up here. Factors of negative 12 that add up to 2. And we've got 6 and negative 2. You can reverse the signs there. That won't work. And you've got 3 and 4, and again, one of those has to be negative, so we actually can't reduce that. So let's go ahead and start with our vertical asymptotes. And again, all these are kind of paired together. Vertical asymptotes, domain, and removable discontinuities. So we take our denominator, set that equal to 0, and since nothing will cancel, we do not have any holes or removable discontinuities. And our vertical asymptote is at x equals 5, which again, all of these apply to our domain. So our domain will now go from negative infinity to 5, union 5 to infinity. And then I'm going to go ahead and just put that on our graph as a dotted line. Okay. All right, so now let's go along and think about our horizontal and then possibly even slant asymptotes here. Okay, so if we're talking horizontal, we got to look at our degrees here. Well, in this case, it's going to be top heavy because our degree here is 2. Our degree here is 1. So if that is top heavy, we have no horizontal asymptote. We are going to then have a slant asymptote. So we can do this in a couple different fashions here. Let me go ahead and erase these degrees that I highlighted there. We can do long division or synthetic division. Since this is in the form x plus or minus a number, very, very easy to just go ahead and do that in terms of synthetic division. So let me go ahead and do that. So again, remember it's not negative 5 here in our little bracket, it's positive 5. Bring down the 1, multiply, add, multiply, and remember you are going to have a remainder. We don't even care what this number is here, you will have a remainder. These values right here become your asymptote, so that's going to become y equals x plus 7, and again that is going to be our slant asymptote, y equals x plus 7. So we got a nice y equals mx plus b, so we can go ahead and graph that starting at our y-intercept of 7. And then our slope is going to be up 1, right 1, up 1, right 1. And you're going to see here, I'm even extending this vertical asymptote. We got kind of a little X shape going on here. But I'm going to keep going with my, oops, that one was wrong. Keep going with my slant. I'm just going to keep filling up my graph till I start kind of running off there. Again, with a slope there of positive 1. All right, I'm going to come back to end behavior. I'm going to jump down and start doing some of my zeros here and my y-intercepts. Okay, so zeros, again, these are really going to be our x-intercepts. So if you recall, we are going to set f of x equal to 0. So we're always going to have something, comma, 0, right? Excuse me, your y value would be 0. So whenever you solve that, some of you might even skip this step. I'll do it probably on the next one. Every single time, this denominator, you're going to have to multiply by it. You get 0 there, so it just goes away every single time. So if you want to just start here, setting your numerator equal to 0, that absolutely will give you your zeros, or in other words, x-intercepts. We talked about this before. This one does not factor. So what are our options? Complete the square, quadratic formula. I'm assuming most of you will probably pick quadratic formula, which is fine, doesn't matter either way. Opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. And now we're just going to simplify inside that square root. So we'll have 4, and this is going to be negative 4 times the negative 12 essentially, so plus 48 all over 2. Now just continue this along over here. So x equals -2 plus or minus square root of 52 over 2. And let's see if we can reduce that. Well, I know 4 goes into that. Right, 4 times, what's that going to be? 1 times 13. So that'll be -2 plus or minus 2 root 13 over 2. And we can just keep simplifying, cancel the 2 out of both of those. Remember, the 2 is underneath both the -2 and the 2 root 13. So that'd be x equals -1 plus or minus root 13. Okay, so we're going to go ahead and leave those in that exact form when we write them down. Oops, that's supposed to be erasing. There we go. So -1 plus or minus square root of 13, comma 0. And then we'll graph those in just a moment. I'm going to use our calculator here to aid us with that just a little bit. And then we need to find our y-intercepts. In this case, we always set x equal to 0. So if I come back up here, here's our original equation. So again, all of those are going to turn to 0. So we're going to have f of 0 equals 0 squared plus 2 times 0 minus 12 over 0 minus 5. And again, especially when it's not factored, this is all going to go away right here. So it's really just going to be this -12 over -5, which is 12/5. And we can go ahead and graph that one because that's 2 2/5. So we can come up here. So that's going to be in between, again, ballparking that in between 2 and 3. And then we'll come back and talk about our zeros and then fill in our end behavior here. But I'm going to go ahead and use our calculator at this point in time just to kind of verify and fill in some items. Let me move that over here. So first of all, let's do the zeros. So that'd be -1. I'm going to do plus square root of 13. (2.6). Come over to my graph that one. And then we'll do the minus. So that's -1 minus square root 13. And that's -4.5-ish. And hopefully you can even do that because you know that this is going to be, it's in between the square root of 9 and the square root of 16. So that would have to be somewhere like between 3 and 4, the square root of that. So approximating that. Okay. And then I'm just going to verify this in my calculator. Now remember, when you graph this in your calculator, you need to put parentheses around your numerator and denominator. So here I have x squared plus 2x minus 12 divided by the quantity x minus 5. And we're going to go ahead and verify it and graph it. And I'm going to point out a couple little odds and ends. So remember, your asymptotes don't actually physically show up. That's why we put them as dotted lines. But we don't have anything going on up here, which is kind of why I wanted to actually show you this graph, because you can see how this makes like an X here. We definitely have this graph here, this portion of it going on, where it goes along our slant and our vertical asymptote. But there actually is another portion up here. Not terribly worried about that, but if you take and change your window, if I extend my window and make just my Y values larger, I'm going to go something 50, something fairly large, so I make sure that I see it. Push graph, and you're going to see there's the bottom portion, and then you're going to see another little portion up there. So I just kind of put a little portion up there, not terribly worried about that. So if you just want to put a little portion on there, just like I did, that would be fine. Okay. And last but not least, we have not done our end behaviors. So remember, we're always filling this in. As x goes to infinity, what's y doing? As x goes to negative infinity, what is y doing? Okay. So as x goes to infinity, this is obviously going positive infinity. The y keeps getting higher. As x goes this direction, negative infinity, this is now going lower, so that's going to negative infinity. Okay. All right, so this is problem number 1 from practice number 3, and I will also do another problem as well, but this is problem number 1.